Live. So let's just make sure that we are in fact live. Okay, so we are live. Welcome back, James Lambert, to the show. We of course. I need to turn myself off here. Except the chat open on my phone. Don't have two screens anymore after my postdoc move. So welcome back, James. It's been a while since we've had you on the show. So why don't we start the show by getting caught up with you? You recently finished your PhD.
Yeah. Thanks for having me back on. It's always fun to stop in and chat. And it's nice to see you on Zoom because we haven't seen each other since your move to the UK.
Yes.
So yeah, I finished my thesis in December, and since then I've been teaching a machine learning course at McMaster, and I've been sort of hunting around. I'm kind of in that intermezzo period between grad school and then whatever the rest of my life is supposed to be. And so,
I guess it's an interesting stage to be in, though, right? So. I mean, we don't have to go into too big of details, but do you want to say the title of your thesis and the main sort of the main focus of it?
Sure. So my thesis title was state space geometry and low dimensional quantum magnets, and basically my research focuses on this idea that you can think of the space of all possible states that might describe a physical system, yep, in terms of how distinguishable those states are from one another. In an experimental sense. And this notion of distinguishability gives you a notion of distance, and then it allows you to talk about the geometry of these state spaces. And so in particular, I was very interested in how this geometry relates to these phenomenon like quantum entanglement or quantum coherence, which is a sort of a big deal in condensed matter physics and all kinds of disciplines, really. So I'm actually in the process of, it should be up on the archive probably in the next week, writing a pedagogical introduction to the field. So if anyone is interested, I'll just take this chance to plug my work. If anyone's interested, they can go and check that out. And it sort of takes you through the whole story from classical information to its applications in quantum sensing and quantum condensed matter and so on. So
I have had the luxury of seeing the sort of like the outline and skimming through that. It does look like a fantastic resource. Like there's nothing really else out there, in my opinion, that would be as good of an introduction as what I've seen from James.
Oh, thank you. I appreciate that.
Okay, so now that we've done a little bit of catch up, why don't we jump into the topic of today? So something that James and I often talk about privately amongst each other is, and probably that we've had influences on each other through these conversations, is how our scientific worldview, our understanding about truth has evolved like over the years. Basically from childhood to today, I would say that's been a very sort of fluid journey with lots of changes. And as always, at every step of that journey, I'm extremely confident in my answer, and I'm going to be confident in my answer today, and I'm sure James is as well. So it's going to be more of, instead of focusing on some particular type of physics, we're going to tell a story today. We're going to tell the story of how James has particularly evolved in his worldview while he does science, and I'm going to chime in with some of my stuff. So why don't we start off young, as you suggested, and sort of talk me through, what were your early impressions of truth seeking in I don't know, like as a human, I guess.
Yeah, so I was raised in a sort of somewhat religious household and had a Catholic school education, and religion gives you a pretty clear answer, or I think it, for a lot of people, gives a pretty clear answer to this notion of truth. And that notion relies on, in the case of Catholicism, an idea of God and of religious truth and spiritual truth, and that the world kind of hangs together, kind of coheres. Actually, the motto, the Greek motto of the university, which is our shared alma mater, McMaster, is "All things cohere in Christ." And in Catholicism, yeah, that is the motto of McMaster University, or in Christ all things cohere. And so, Catholicism, Jesus is God, and the worldview that I was sort of first exposed to I didn't like church. I thought it was boring, so I thought I should go out and find a different way of explaining truth that didn't involve me getting up early on a Sunday. And what I came to was what I sort of now consider to be a kind of scientism, and maybe we'll unpack that word as we go a little bit more. But basically, the idea that science is the kind of ultimate judge of truth in the world, insofar as we can, maybe mathematics, but something like scientific or mathematical truth is kind of the only kind of truth you can really get down to. And anything else that people might be talking about might be useful for them or interesting to them, but it's not, it doesn't have to do with facts and reality. And I think that an important aspect of what I'm going to call scientism is not just the idea that science is the arbiter of truth, but that's a good thing. And we should really be embracing that. And we should, you'll hear people say that, we should follow scientific facts and scientific expertise. And that's really how we should govern our society and our lives. And, facts about the world should be at the core of that. And in particular, facts about the world as determined by the Western European scientific method. So this was something that I was, growing up in Canada, exposed to from all kinds of different places. And I certainly felt like it was a view that was given to me through a lot of popularizers of science. This is, even Bill Nye, the science guy, right? Like, what's so great about science is that, it's that science gives you the truth and a picture of the world. And so that was sort of my genesis in science, and maybe a big part of why I wanted to study it was because I wanted to understand these ultimate truths, these sort of truths with a capital T that science was promising to expose me to. And then when I got to my undergrad, I had a lot of friends who were physicists. They were studying. Yeah.
Let's. I feel like there's like a lot to unpack from what you just said. So let's first unpack the big T truths, right? So when you're growing up as a Christian, or I'm assuming in other cultural contexts, you're presented with a way to understand sort of objective reality in a way that objective reality is obviously out there. There is some type of like coherent set of rules that are governing reality, and in particular, I think you sort of come to understand that these types of laws, like as a human being, those are accessible to you. Those are understandable to you specifically, right?
Yeah, and I think that made it very easy to replace, in my mind, the Catholic truth I'd been given with this kind of scientism kind of truth, because the structure is all the same. There are laws. It's not God determining them. It's scientists or nature or something like that. But the same philosophical structure is there. We're just sort of relabeling it a little bit. I guess.
I think that's a topic that I don't think is explored or talked about enough. Is that, like, at the end of the day, when you're doing science popularism, or even you're teaching science to like undergraduate students, graduate students, or you're writing articles, like the people that are reading it within like a cultural context that's really important. And the cultural context that I also grew up in was I was raised Catholic, and that is the cultural context that, like, I guess I had to start in, as well as you, to start like digesting science. So science, you replace this objective truth given to you by your upbringing, your cultural context, with this truth-seeking sort of algorithm that is science.
I think another important thing that we have to maybe bring in here, another important part of the cultural context that you and I share, and that I think a lot of folks watching this share, is this idea of progress, right? As a child, you're sort of taught things used to be awful. So like 1,000 years ago, people lived very difficult, challenging lives, and they didn't have iPads, and they didn't have Uber, and they didn't have the internet. And science gave us all these things. So, in much the way that the Christian worldview maybe conceptualizes the good in life as coming from God and the rightful following of God, scientism kind of conceptualizes the good in life. First of all, it defines the good as anything science happens to have made for us. And then it says, that we should be grateful for that. We should be grateful that science has produced all this wonderful technology, because our lives, apparently, according to this worldview, our lives are apparently better for it.
Yeah, I guess I found myself susceptible to that earlier on, but I think most people that you would meet would have a more nuanced opinion of science, even if they're very, if they prescribe to scientism or some type of scientific realism or something like this, most people would agree that science has given us some awful things.
Yeah, I think so. I think that, I think the most dominant view that you encounter amongst people who study science is that science is kind of a priori neutral.
Yes.
Morally speaking, and then it's all in the application. If we can use nuclear technology to, stop climate change, that's wonderful. But if we use it to build bombs, then that's horrific. And sort of in that, in between those two things is the sort of whole world of possible, moral applications of science.
Yes. So would you stand on the side of today as science is neutral? I guess I would. Like, unfortunately, it's really, like, if you use it as a truth seeking algorithm, then it's sort of just it is neutral. It's sort of up to the person practicing it to.
Yeah, I think that it's. I guess one thing that I would say is, so if that was the start of my journey, to bookmark this whole thing so we can kind of roadmap this discussion, the end of my journey is that I'm confidently unsure of everything. And and in particular, I feel like when we say, for example, what is the moral character of science, we have to dig into a little bit, like, how is it applied, right? So I agree that the process, if what we want, and we kind of get into this thing called the demarcation problem, right? Like, part of the sort of quagmire that we get into here is, like, what even is science really? And so if we kind of take as a kernel of the definition this process whereby I experiment and I observe and then I iterate and I try to create a kind of story of the world that allows me to cohere all of these different experiments that I'm doing and all the observations I'm making. I try to fit them together into one sort of coherent story. If that's kind of what the process of science is, I would say that's not only is that pretty neutral, but actually I think that's kind of what we're doing in almost every discipline that humans are pursuing. If you're a painter, you'll paint, you'll look at what you did, you'll experiment, you'll iterate, because you're trying to achieve some particular effect. That process of experimentation is almost universal, and so in that sense, you can't really say that it's good or bad. But science as an institution in our society, if we think of science as what happens at CERN, or building particle colliders, or building reactors, or investing in experiments or quantum computers, if that's what we think of as science, I think that I'm a bit biased to think that actually it's a little bit morally harmful, because we're in a world now where we sort of pour all of our hopes and dreams for a better planet, or a portion of the population pours all their hopes and dreams for a better planet into this sort of quasi-mystical process of science. You hear people talk about climate change. A lot of the solutions to climate change have been known for centuries, if not for millennia. People thousands of years ago didn't have the technology we have now. They lived in many cultures. They lived in much closer harmony with the land and with the world around us. So it's not like as if we need some fancy new invention to solve this problem. But I think there is a kind of general belief that just on the horizon is some piece of technology that will totally solve things like poverty or solve things like climate change, and we just have to wait and pray until the scientists come up with a solution. And I think that that's very harmful, because it causes us to underestimate solutions that don't sort of fall within this regime of knowledge, this sort of Western scientific regime of knowledge.
Right. So
in that sense, maybe, yeah.
Yeah. So if I could understand your point, like your point is that in some sense, scientism and maybe the popular understanding of science and the institutions that perform science today, they sort of, you might find a lot of folks in those in this sort of area that would be more willing to say that we should tech out of our problems, like we should technologically advance out of our problems rather than consider like other solutions. Science is the savior rather than it is just a truth-seeking apparatus. So one application of science that is happening today is narratives of how do we solve modern day problems, I suppose.
Yeah, I think that it's hard to even talk about it, because there's a kind of code switching that happens. Like, these two meanings of the word science get used interchangeably, and it really muddles it all up. Like, obviously, someone could come back and rejoin, well, what are you saying, that we shouldn't base our policies on facts? And it's like, of course, that's not what I'm suggesting, but it seems to me a bit strange that science gets to claim the monopoly on facts, and some of that's a bit of what scientism is also about, is this idea that science gets to claim a kind of monopoly on facts, kind of in a way analogous to how Catholicism tries to claim a monopoly on morality. Catholicism kind of wants to say something like, you can't really talk about right and wrong outside the context of, and when I say Catholicism, I mean sort of catechism and how I understand what I was brought up to believe in terms of the Pope and the ecclesiastical structure of Catholicism. So I think that's really what I'm kind of coming for here. Yes. When I say that science represents something that's problematic. It's not the process of experimentation. That's wonderful, and that's, like I say, kind of ubiquitous even outside of what we might traditionally call science. It's more this process whereby we say, okay, well, more technology is better. If we have more technology, then our problems will disappear. And the arrogance of scientism is that it totally ignores the enormous body of work in other disciplines in the humanities, where people have been thinking about these problems and understanding them for a very long time. And that's a real naivety on the part of science, I think, to ignore all of this other work that's been done, which just, it doesn't fall in, how do you do experiments in social sciences that are ethical, right? Like, you can't, one of the limitations in social sciences is that you can't do a lot of the experiments that you might want to do in order to come up with hard, concrete data. You can't take a child and raise them in totally engineered conditions to see what will happen to them. That's not really considered appropriate, for good reason. And so in social science, so in social sciences, you have to look much more at this kind of, it's almost a bit more like a kind of archaeology of ideas. People have to go and they have to read history books and they have to read accounts of what was going on, and they have to analyze our society as it exists. And you can't really propose rigorous, repeatable experiments in the same way that you do in physics, for example. And consequently, the notions of truth that you come up with in those disciplines are just a bit different, because the sort of criteria are different. It doesn't mean that those notions of truth are less valuable. But I think scientism, which is a sort of belief system that I think we're all a little bit exposed to in industrial countries, tends to underemphasize the value of that kind of knowledge quite drastically.
Yeah, I think that's an important point. And just to reiterate, so if people just tune in at random points, hopefully they'll land on James' disclaimer or my disclaimer, is that there really is the like two different things, that sort of the scientific workhorse that really drives like industry and advancement and making money, and then there's scientific inquiry where we are genuinely interested in how the world works. Like these two things, like one is really an institution, and one is, it's just inquiry. It's just experiment. And these are two really different things that like, unfortunately, you can't talk about one without the other, because as of today, probably the most popular scientific worldview, or things that you see in the media with science popularizers, is these things seem to be the same. They're pitched as the same thing, when really these are like extremely different things. Like if you really boil it down.
Yeah. I feel like sort of the discourse about the philosophy of science, as we are going to sort of engage with it, or I think, or as I understand how we're going to engage with it today, really falls into the latter of the two camps. We're really interested, I think, today in this conversation about, what is science actually doing, and how does science relate to the real world, and is there a real world, and what is all this? And I think that, it's kind of like having put the goalpost down is important, I think, to recognize this demarcation between the institutionalization of these philosophies and then the philosophies in and of themselves, which, are separable.
Yeah. So the road so far was you were raised Catholic. You then became an atheist almost out of rebellion, and you looked for a replacement to Catholicism, and you found science. And
yes,
that probably sounds bad, because I know there's lots of talking points out there that say, some folks treat science dogmatically. What would you say about that?
I was confronted by those points a lot when I was young and argumentative about this. In my religious religion classes and so on, people would raise the religion. And at the time, I really bristled at that. But in retrospect, I think that's a pretty legitimate comment, actually. I don't really. I think that actually probably does align more. I don't believe in any particular religion, and insofar as I have spirituality, I don't really know how I would even characterize it. But I definitely agree that the sort of way in which I was engaging with science, and I think the way a lot of people engage with science, it does sort of border a little bit on something that looks a lot like a religion, and I think that we're really discouraged. I found, at least, kind of the next stage of the story for me was going off to university to study physics to find all these wonderful absolute truths about the world that I'd been promised. And then discovering through friends who were studying philosophy of science that actually the world was a lot more complicated than I'd been led to understand. And this whole question of truth was actually a lot more complicated than I'd been led to understand. And I wasn't really encouraged to engage with that through my classes in physics and mathematics. I was encouraged to engage with it by proxy through philosophy and through friends of mine who were studying philosophy of science and who really didn't let me get away with my kind of dogmatic approach for very long.
So Joey, yeah. Our good friend Joey has a fun question. What's up, Joey? I hope to see you at some point in the future. Can you work, i.e., make money, pay bills as an inquiry-focused scientist outside of an institution? And obviously, the answer to that is obviously no, right? Like these institutions are to perform modern day science. The questions that are currently funded, usually you need a lot of money to do these things, of course, and it's difficult to do these types of inquiry without a lot of time and freedom, of course, right? And institutions can give you that, but there are strings attached. But
in principle, you need tenure, right? I mean, in principle, that was the whole point of tenure, was that once you got tenure as a professor, in theory, you would use the academic freedom and the access to resources that you now had to pursue, just really inquiry-driven research. In practice, though, the academic economy just doesn't really work that way, and I think that this is something that everyone kind of knows. I don't know if there's really an easy solution to this problem. I don't even know if everyone acknowledges that it is a problem. I think some people see this as a perfectly acceptable status quo, but we do absolutely live in a world where, like you say, you can't do any research if you're not funded, and so at some point along the line, you have to appeal to the institutional objectives, the objectives of the institution that's going to fund you.
Sort of agnostically, or I don't know if that's the right word, but like in principle, if you have institution A and they want to make a push in subject B or something like this, like in principle, hiring people to push those subjects doesn't seem, a priori a bad thing. Like I think,
No, I mean not any worse than any. I mean, it's just like any other kind of hiring that goes on, right? Like, you hire wage workers to do some job because you think, basically the ethics of this are kind of the ethics of money, I guess. Really, it's the same ethical question we run into when we have any powerful institution directing people to any kind of labor or another, which is kind of a whole other topic. But that's, I think you're right that a priori it's not really that different from any other part of the economy. Scientists produce papers, they produce experiments. Some people produce cars. It's just a different kind of labor. I think what's really revealing, though, is how valued it is relative to how useless it is. We fund, like, scientists receive pretty incredible salaries, especially if you're a tenured professor or if you're a researcher at a big institute, or if you work in the private sector. I mean, you can make enormous amounts of money researching incredibly esoteric topics that aren't really going to trickle down and make the average person's life that much better in the short term, and perhaps not even in the long term. And then meanwhile, people who actually feed us, are paid relatively less. So that's an interesting observation. One can make of it what they will, but yeah.
All right, so let's start talking about your undergrad. So you enter undergrad just like me. I was very sort of science is the only way to discover truth. The truth that we're talking about in these classes, like these are the laws of nature, the underlying code of the universe, right?
Yeah.
So how long does that last for you, and how does that sort of get deconstructed initially?
So it kind of comes about actually almost chronologically from a historical perspective. So one of the first things, so I had to begin to refine my position a little bit. And so the first thing I got exposed to was positivism, which is this idea advanced by Karl Popper, amongst others. I should say, as I'm talking about this, I'm not an expert in philosophy. I don't have a degree in philosophy. So as I'm saying this, I'm going to try to give citations for folks if they want to read more, and know that you're hearing this from an amateur. But basically, positivism is an idea which I actually think most physicists never get past in the philosophy of science, which is that something is science. And so here we're talking a bit about what is science, right? That was the first thing I had to figure out when I got to undergrad, is what are we doing in science exactly? And positivism is basically the idea that, and post-positivism is the idea that science is wrapped up in this idea of falsifiability. So if I make a statement and that statement is falsifiable, then that statement is a candidate for science. That's sort of the positivist perspective. And I was pretty happy with that, because that allowed me to maintain basically my entire worldview. And it just gave me a bit more of a refined way of talking about what science is and how it functions. But in philosophy of science, that view is considered, I think, quite outdated by most people. And so one problem with this worldview that was presented to me is that it's not really self-consistent. Like, is that statement in and of itself scientific? Can you falsify the statement that science is about claims that are falsifiable? And the answer is no.
But it seems to me like the definition of science is subjective, and then you just move on.
Well, yeah, that's kind of the move you have to play. You basically have to say, well, I'm not doing science to get myself going. I define science in a way that isn't part of science. But now you run into a real problem if you're a scientific realist, because if truth in the world is mediated completely by science, and the foundation of your definition of science isn't scientific, then is your definition of science admissible as a kind of truth in the scientific sense? And the answer is no. So you kind of have to accept the fact, if you sort of follow this line of reasoning to its conclusion, if you sort of say, well, okay, I think truth comes from science. What is science? Science is falsifiable claims. Okay, but that claim's not falsifiable, so it's not true in a scientific sense. So the foundation of truth is a claim that isn't true. And you run into this kind of contradiction, and so positivism begins to sort of fall in on itself. And sort of what comes in its successor, and you know, I'm kind of now describing this as I describe this. I'm kind of describing my own journey here. The successor argument, one of the successor arguments I was introduced to, is from this guy Quine, right? And so Quine, great philosopher of science, and Quine basically says, you know, you have a mesh of beliefs. You know, you've got a big mesh of beliefs about the world, and these beliefs connect onto each other. And the more embedded a belief is in your web of beliefs, the more likely you are to hold on tight to it, as opposed to a belief that's at the periphery. You know, so for example, you know, I'm pretty sure I'm 28 years old. I'm pretty sure I was born on May 29th, 1994. I think that was my birthday. And there's a whole bunch of other facts in my life that kind of corroborate that belief. So I'm really disinclined to release that.
Yeah.
But you know, you know, by contrast, for example, by contrast, you know, I think that Quine was doing all this work in around 1950, but I'm not really that sure about that. And if someone came on and challenged me on it, I'd be happy to just abandon that statement. So that's kind of an example of how the web of belief works. And what Quine wants to say is that that's kind of what science is. You know, science, there's a kind of nucleus of things that constitute science, and in part that means experimentation, but it also means building a coherent story that links the experiments together. It means making predictions and retrodictions, and all of these things are sort of part of science. And so there's a kind of core of science, and then there's a kind of penumbra of science. There's a kind of bunch of things that are kind of they're kind of science, but they're not really science. So Quine's account of science, this definition of science, does allow us to kind of preserve the belief, if we want to, that science is the arbiter of reality or truth in the world. You know, believing in Quine's view lets us say, okay, science is the arbiter of truth and reality. The boundaries of what science is are a little bit fuzzy, but there are things that are at the core, and those things really do define, you know, what the facts of the world are, and what the truths of the world are, and how they're all related up together. And that's kind of maybe the next another stage on this journey a little bit.
So that does seem like, you know, relatively reasonable. I mean, starting from a very subjective starting point and then defining how you're going to truth seek. I mean, like, that's not like in a way that, I mean, you can build consensus with a number of folks that's a good way to truth seek. Is there some glaring issue with that I'm not seeing?
Well, there are a couple of interesting things about this worldview. So one thing about this worldview is that it still allows us this idea, and anyone who's done statistics will be familiar with this, but you never prove anything true. One conclusion that you can draw from that, you only ever prove that something isn't false.
Yep.
Okay, so that's kind of an interesting observation. And then you can get into some kind of strange conclusions. So there's this idea of Quine's that comes out a bit later about the indeterminacy of translation. And basically Quine says that on a certain level, you can never really translate any sentence to any other sentence, or even be sure that when you hear someone say a sentence that you even know what they mean by that sentence. You can behave accordingly. You can hear someone say a sentence to you, and you can behave in a way that both you and the person who just spoke seem to kind of agree is reasonable. But can you really be sure that you knew what they were saying, that you understood what they meant? And the idea here is that if you create a sort of pattern of language that's complicated enough, or rules for language that are sufficiently complicated, you can kind of derive any meaning from any sentence. And there's no real way of being sure about what the true meaning of a sentence is. And it's kind of just a matter of practicality that we don't worry about this fact. Somehow it just happens to be the case that when I say something like, could you pass me that glass of water, to someone else who speaks English, and they know what I mean, and they pass me the glass of water, and I say, oh, excellent, I've communicated with them, they understood what I meant. That's all I really needed. I just needed the water. So it doesn't matter so much whether or not they really knew what I was saying. And Quine's observation is that you can't really ever be sure that they knew what you were saying. All you can know is that they gave you the glass and that's what you were expecting. And that's kind of a metaphor for the scientific process. I can go out and I can make measurements and I can say, yeah, those measurements are consistent with, quantum electrodynamics, and it all checks out and it works. How can I really be sure the universe isn't trying to trick me, that there aren't some very, very complicated laws that are really bizarre and the laws just conspire to give me exactly the results I would expect for quantum electrodynamics over the last, 100 years or so since quantum electrodynamics.
What do you mean by that? That seems a little out there. So let's clarify that statement a little bit. They could be time-like in a way that we don't understand, for example.
Yeah, maybe there's a time dependence to all the laws of nature that's really complicated. And I don't know, maybe 3 years from now, all of a sudden, all the physics that we understand totally change. All the laws of nature will be different, gravity will be repulsive. And all of a sudden, what happened to our precious laws of physics? Do we still believe in those laws? Suddenly, no one thinks that that's the sort of counter argument to that as well. We'll see. It hasn't happened yet. And scientists, I think, take a very practical view of this question. If you speak to people who actually work in physics, they'll say, who cares? I'm paid to go out and explain why this material is conductive in such a way that we can manipulate its conductivity. And I did that. So, what are you talking about when you say, well, what is the material actually doing? Are there actually electrons? Like, these questions just aren't really relevant because physics is this, today at least, and this wasn't true hundreds of years ago, but today as a physicist, your job is to make predictions that can be checked in experiments that can be used to intervene in the world in a way that's kind of predictable. And as a scientist, you just don't really worry too much about, quote unquote, what's actually, it's not even clear that you can define that concept clearly, like what's actually going on versus what we observe in every circumstance to be going on.
Right. I guess this is a really interesting sort of point to stop at and stick around a little bit, is this point of like the stories we tell ourselves and like the difference between predicting the outcomes of experiments and then also communicating a coherent story sort of in, regular language about what's happening to make the outcome of the experiment the outcome of the experiment. Like it's difficult to explain what a wave function of what a wave function of some quantum system is. But if I make up a story about, quasi-particles and they're interacting and bouncing off each other and like all of these nice ways, and that's sort of like that's a fun story to tell other people, and it's also a very intuitive story to help you do science. But I guess that I don't entirely know where my point is for this, but like these stories that we tell ourselves don't necessarily, and probably don't in most cases, actually align with what's happening, right?
Yeah, I guess this is really the like this is a big debate, right? In the philosophy of science is like, let's just grant, for the sake of argument, that there is the world as it actually is. Let's just pretend that that is a concept that we can talk about. And then we talk about the world of experience. There's the world as we experience it through our senses, and maybe we extend that even to our scientific instruments. And the question is, are these the same? Do they map onto each other? How do they map onto each other? These are the kinds of questions that we're asking. And so a good story to tell here, I think a story that's quite useful to tell, is the story of gravity. Okay, so for a long time, 2,000 years ago, people believed that the motion of the planets in the sky came from, the divine in some sense. The gods just built the universe that way. That's how it functioned. And that went on for a long time, that people believed in this kind of idea, this Aristotelian idea of gravity. Aristotle said something like, objects have a destined place in the cosmos, and as they did all, I think we might have.
I got you back there. It froze a little bit.
Okay, I turned off my Wi-Fi so that would. Sorry, how far did I get in that?
You were talking about. Just start us from 2,000 years ago again.
Okay, let's start from 2000. So 2,000 years ago, Aristotle says something like, things in the cosmos have a destined place of rest, and that's why they fall. They fall because they have a destined place of rest. 2,000 years ago, people didn't really, this is also kind of an interesting point, people didn't really conceive the motion of things on the surface of the Earth like an apple falling. They didn't think of that as being the same type of phenomenon as the planets moving in the sky. All of these things were happening according to a kind of, structure or form of the universe that the universe was kind of fulfilling through time. And there are all these, classical debates about this question. Okay, so fast forward 2,000 years into the 17th century, you come into like a European context where people are very interested in, machinery, and there's this new phase of scientific skepticism. There's the Protestant Reformation, and you get people who basically come to the conclusion that the universe is a big clock. Okay, so kind of the same as the classical idea. You've got the universe is like a big machine, and gravity is a mechanical phenomenon. So one of the theories, for example, of how this might work is that passing through us from all directions are tiny little particles, and we don't perceive them because they're very small. But these particles bombard objects like the Earth, which are quite massive, from all directions equally. And the sun occludes the motion of the particles from that direction. And so the net force of the particles is to push the Earth into the sun. That's the mechanical theory of gravity. And people really thought that some version of that was going to turn out to be correct. And then Newton, who also believed in this, by the way, said, well, I can't really make it work with this theory of the little particles, but if I just imagine that there's a mystical force, the force of gravity, I actually get all the predictions right. Like if I imagine that there's this mystical force, I can rederive Kepler's laws of motion, and I can tell you exactly where the planets will be given their positions at this moment in time. And amazingly, I can connect the motion of the planets to the motion of an apple falling from a tree. So actually that apple falling from a tree, that's the same type of phenomenon as the moon orbiting the Earth. So that's a great breakthrough. And then we say, okay, we've arrived at the story of science. And some time passes, and it begins to become clear that there are aspects of this story that are sufficient. For example, there's a phenomenon, very famous phenomenon, the precession of the perihelion of Mercury. So this is a phenomenon in the orbital mechanics of Mercury around the sun. And Newton's theory of gravity just doesn't explain this phenomenon. So then Einstein comes along, and Einstein proposes a new theory of gravity. He says gravity is not about mystical forces. There are no mystical forces involved in gravity. Gravity is about geometry. So everything in the universe is trying to follow a geodesic. It's trying to follow a straight line. And mass and energy curve space and time so that a straight line for an object moving through curved space-time appears curved, like an orbit, for example. And this theory ends up explaining not only the precession of the perihelion of Mercury, but even, for example, the way that light bends around massive sources of gravity. So, for example, if you look at the position of stars in the sky, and then you wait until some massive object like the sun comes between you and the stars, the position of the stars will appear to shift. And that's in Einstein's theory due to the fact that light, even though it has no mass, is following a geodesic in space-time and curves around the mass of the sun. So great. Now we have a new theory. It's totally different from Newton's theory, which is totally different from the mechanical theory, which is totally different from Aristotle's theory. It's more predictively powerful. Is this theory the truth? Is this theory describing the world as it actually is? Well, we know that this theory also has its limits, right? We know that there seems to be some really fundamental set of problems when it comes to unifying this theory and making a cohesive story between this theory of gravity and our theory that describes small particles in the universe. And so the solution to that conflict might be a whole new way of thinking about the universe and about gravity. And okay, will that be the one? Will that be the story? And you can kind of see the problem here is that each time we come up with a new story, that story relies psychologically on very different concepts. We went from mystical forces to geometry, and then maybe on to some new theory in the future. And there's a position which I think is kind of fun called pessimistic meta-induction. And basically this theory says, yeah, this is just going to keep happening. You're just going to keep going and making more theories. And, your theories will get you good experimental results and you'll refine your ability to predict experiments. But the story you're telling doesn't need to have any bearing on, quote unquote, the world as it actually is, if that is indeed a well-defined concept. And so this is kind of an interesting view, I think, on science.
So if you read James's book, in the first chapter, he has like he has like a little section called Analogies with Physical Theories, because this is his book on plausible reasoning, like the logic of science. And what he says is, what we do in physics is we try to model things, and when the models get more accurate, I'm paraphrasing here, this is not an accurate retelling of what he says, but when the models get more accurate, or we're able to reproduce predictions for more and more observations that we previously couldn't predict correctly, then we say that we've made progress, right? And this is this process that you've said, like every time we make progress, every time we have a new theory, we make better predictions, and we're happy with that. And he goes on to say, no one knows whether this process will ever end.
Yeah, this is called the end of, I guess, is this asymptote. And the other phenomenon here, right, is that as we learn more about the universe, we can ask more questions that are more specialized. And so it does feel, I think, especially, today in physics, looking back on kind of the scope of the history of physics since the mid-17th century, it does feel like as if we're getting into finer and finer grades of minutia and more specialized fields that are harder and harder to connect with other fields, just because practically it's hard to have enough knowledge to be able to see the connections between this sort of burgeoning frontier of understanding. It's hard to be an expert in one particular part of quantum mechanics and then also an expert in some particular part of soft condensed matter physics. And these branches are really spreading out in a way that makes it difficult to find. It doesn't mean that unification doesn't happen. It just means the sort of process gets more and more difficult as we go along.
And so like one thing that I just want to backtrack on and sort of double down on is this idea that when you see popular like science populists talking talking about why can't I speak? Science popularizers when they speak about general relativity today. They talk about it, this is the way the world works, right? But they're also very clear that there are issues with general relativity in our understanding of gravity. And from a historical perspective, it's very clear that if we do improve upon general relativity and we do start talking about and improving upon its predictive power, that might come in the lens of some new type of theory that recovers all of the predictions of general relativity. Like general relativity recovers all of Newtonian mechanics and specific limits that are, of course, you want that to be true. But then it might come with a completely different conceptual framework and a completely different story that we tell ourselves to understand this conceptual framework, right? So like like the revolution in gravity might not preserve the story that we're telling ourselves today about gravity.
But it will, this is an observation that they sometimes call epistemic structural realism. So this is the idea that, so in philosophy, right, epistemology is about your state of knowledge. and ontology is about the state of the world as it is. So when we talk about the actual world, insofar as that's a concept we can talk about, we're talking about something ontological. When we talk about our knowledge of the world, we're talking about something epistemic. And so epistemic structural realism says that the structure, the mathematical structure of these theories, as you say, is preserved, kind of nested within these bigger structures that we keep adding to improve the predictive power of our theories. And it is this structure which is real. So the epistemic structural realist wants to say something like that structure that we're building, that mathematical structure, whatever stories we might be telling to help ourselves remember how to put the symbols on the page, it's that mathematical structure that represents our knowledge of reality and sort of grows monotonically.
Would you disagree with that though? Because that's basically what seems to be happening, right? Like we're making predictions, we make experiments, we see what's happening in experiments and we do these experiments, in different regimes and different, scales of different things. And our theories are able to, in certain limits, and not like from the human perspective, these limits are extremely wide. What we're able to predict, like the areas that we're having difficulties with, seem very extreme to me at face value. So what you just defined as what was epistemic realism, that does seem to be what the project of physics is.
Well, I think that the philosopher would say, I think that if you're a physicist, you're quite happy with the statement of ESR, because that's what's happening. It seems like, you do it in class, you do the sort of the low velocity Taylor series expansion for the kinetic energy and special relativity, and you get out the kinetic energy from classical physics. And, that it just seems obvious that that's what's happening. The critique of ESR, as I understand it, is the R part, is the realism part. So the question is, how much is this reflective of reality as it is? And this is where we begin to get into this sort of split between realism and anti-realism. So the anti-realist might say something like, so maybe a citation for this, you could go and look up some of the work of Hilary Lawson. So he's a sort of recent philosopher of science. Another, I don't know enough about her work if I could characterize her in this way or not, but Karen Barad is also a very interesting figure whose work we should talk about here. But basically, the anti-realist wants to say something like, okay, yeah, the universe as it is, like, yeah, maybe that's out there, maybe that's something that's happening, but that universe as it is doesn't have any a priori cuts in it. So the universe isn't broken down into the elements of scientific discourse. It's not like the universe is broken down into electrons and fields and geometries and so on. And the anti-realist wants to appeal to this fact that, throughout history, we've seen these stories change enormously. And the anti-realist would maybe even say, well, yeah, the mathematical structure is preserved, but what are you describing with that structure? What you're describing, that structure, that mathematical structure, is just a story that's helping you do experiments. That's it. It has nothing to do, that structure isn't honing in or fitting some structure out there in the universe. That structure is kind of like a tool, it's like a hammer, it's a tool that you're building to do a task.
So I guess I would be very skeptical of both the anti-realists and the realists. I guess as you know, I lean more to like the sort of subjective side of things. I don't know if it's actually telling, like, for all I know for all I know, that is the real story of the universe. And for all I know is this is a story that we've made up that's extremely helpful for us to do, calculations, right? Like, I don't know the answer and you don't know the answer.
Let me give you a metaphor from Hilary Lawson to maybe cash out sort of what I mean by all of this. So imagine that you live in a bunker and you have a video camera and you can see some flags outside. And maybe you have some knobs in front of you and you notice that turning the knob one way or another influences the motion of the flags outside. And so you get hard to work in your bunker and you come up with theories that relate the turning of the knobs to the motion of the flags, and maybe you get a theory that works really well for you. That theory wouldn't tell you about the wind that was moving the flags. It not necessarily, right? That theory wouldn't necessarily hone. if the flags were embedded in a world where there was windstorms and the knobs you're turning are actually like fans or fins or things that expose the flags to wind coming from different directions, that might not be involved at all in the theory that you come up with. All your theory has to do is relate accurately the motion of the knobs to the motion of the flags. And it doesn't need to talk about wind at all. So that's kind of a metaphor for, I think, what anti-realists are saying about the world. They're saying, the world as it is could be out there. It could have divisions. It could not have divisions. A priori, we don't know what those divisions would be. And when I say divisions, I mean dividing the universe up into things like atoms and molecules and elements and fields and that kind of thing. Whatever way you want to sort of cut up the data of the universe that you're receiving. Those cuts are not out there a priori. They don't need to be out there a priori. What we are doing when we undertake the project of science is we're sort of, Lawson uses this word closure. We're closing the openness of the world, So I look up at the sky and I say to you, oh, well, these stars over here that look a bit like a person, a hunter, I'll call those stars Orion. And once I've done that, I can say to you, well, look at that star over there. That's just a bit to the right of Orion. Well, does that mean Orion is out there in the universe as a sort of ontological object of reality? No, it's just a happenstance of my sense data of the night sky and my particular human brain's ability to make patterns that you and I both picked out that pattern. And then we said, I can use that pattern to do things that are useful for us in the world. But that doesn't mean that Orion, the constellation, was sort of carved into the rock of reality outside of our little story that we're telling to help us navigate our boat or whatever it is that we're trying to do.
So is it like an implausibility statement that I mean, are you basically saying what I said in the sense that, I mean, that that could be what's happening, but like it's probably, are you saying like, just because the story works doesn't mean it actually relates to what's actually happening?
Yeah, I think that's really the conservative statement of the position. I don't want to put a number on how likely one way or another any particular. I don't even know how you'd put a sort of distribution on the question.
We know the answer to that. This channel is based off of the answer.
This is the entree point of Janesians.
Yes, everyone, if you've made it to this point in the video, you should go watch my videos on entropy and Jane's principle of maximum entropy. Mostly a joke. I don't think you should. I mean, it's going to give you no information if you ask the principle of maximum entropy about things like this, because you can't actually test these things. These are untestable statements, so it's kind of a useless application. But plug to the epistemic interpretation of StatMech.
I think anti-realism is really challenging, and I think it's actually really annoying for a lot of people who study physics, because again, physicists and I suspect a lot of scientists working in the so-called hard sciences, the kind of sciences where you can do very controlled, reproducible experiments. This is all very tedious, I think, to them in a professional sense, because it just does not matter to the problems they're trying to solve, and yet, underlying the methodology of their solutions, every scientist holds in their head some philosophy of science, whether they realize it or not. If you push any scientist, they have to begin to tell you what they think is happening. Otherwise, what are you doing? You're trying to come up with a story about what's going on in the world. So I think that this anti-realist position is very interesting because it comes at it from a very different perspective, and it really challenges it in some ways. It anti-realism, right? Like, it is the exact opposite of that position. Maybe say when I was 12 years old, that I kind of believed this idea that science is actually the arbiter of truth and reality and so on. And so then the question becomes, well, can we reconcile all? Is there a sort of framework of thinking that allows us to reconcile all these different ways of approaching this problem? And I guess here is where we sort of enter this discussion of what we call pragmatism, or maybe neo-pragmatism. So in the late 19th century, this guy Charles Peirce, and then a little bit later, this guy William James, really developed this idea of pragmatism, and it had a real clear articulation, I think, in the work of Richard Rorty, who is a sort of recent philosopher working in many areas. And the basics of the pragmatist position are that truth is something that is internal to a vocabulary that we use about the world. So I use a vocabulary of science, I use a vocabulary of art, I use a vocabulary of religion, and all these vocabularies, like tools, are honed to one task or another. And it is that task to which the vocabulary has been suited that defines the notion of truth. Truth comes down to a utility, basically. And so in science, for the person working in their lab, truth is whatever it needs to be to get you to better technology or better experiments or a more cohesive worldview. Or, for a Catholic, truth is whatever it needs to be for you to fulfill your spiritual project, whatever that project looks like for you. And so pragmatism is it's almost kind of like a meta philosophy. It's almost like a philosophy of philosophies, that kind of says that, truth with a capital T, this thing that science claims to be seeking in the first place, just doesn't seem to be a very coherent idea. It's not really clear what that would even mean. Even though we've been looking for it for thousands of years in Western philosophy, we don't seem to be any closer to finding it today than we were like 3,000 years ago. So maybe we should just stop caring so much about truth with a capital T, reality as it is, the absolute truth of the universe. And we should just be comfortable with the fact that we're limited to speaking about truth only ever with respect to a particular end or a particular application. And somehow all of these philosophies of science that we've been discussing, I think, somehow sort of fall in and kind of it can be sort of understood through this lens a little bit.
But this sort of, I guess the problem that I have with these statements is that this loses the focus on reproducibility and being able to falsify statements.
Well, maybe, right? I mean, there are events that might be reproducible. Like, so for example, say that we believe in a religion whereby, at some regular interval of time, we do some physical ritual. Maybe we do a particular kind of dance. And maybe it just so happens that we've figured out that this dance, doing it every day at this time, a geyser erupts. The geyser, we don't know what would happen if we didn't do the dance, because we never do that. But every time we've done the dance, the geyser does erupt. Now, that's a kind of a reproducibility. It's not science per se, because we wouldn't, a scientist would say, oh, well, you should test it by not doing the dance and seeing if the geyser still erupted. Yeah. And you should do statistics, undertake an analysis of it. And that would satisfy a scientist. The scientific project of making predictions about the world would be satisfied by that. But if your project is a kind of spiritual reproducibility, if your project is, okay, I do this dance, the geyser erupts, I feel spiritually secure, I feel secure that today is going to be a good day, or we're going to get a good harvest, or the hunt is going to be successful, or whatever it might be, well, your project has been fulfilled. You don't really care about whether or not your actions are actually in the real world making the geyser erupt. You care about a spiritual project that you are reproducibly achieving with this methodology.
I guess subjectively, I know that I've come to the conclusion that I want to try and minimize bias in the way I think about the world, and it seems to me like attempting to repeat experiments and stress test observations is sort of central to that theme in some sense.
Well, here now I can really bring in this work by Karen Broad. So Karen Broad has a book called Meeting the Universe Halfway. And in this book, Broad basically calls on us to think about quantum mechanics and to basically argue that what quantum mechanics asks us to do is recognize that the distinction between observer and observed is not an objective one.
Yep. That
distinction in and of itself, even to say, oh, I'm the observer and then here's the observed phenomenon, quantum mechanics really calls on us to challenge that idea. And so what Broad proposes, Broad says, in physics we talk about interactions. So we say there's object A or agent A, and then there's object B or agent B, and A and B are interacting with each other. And this entire framework of thinking about science relies on the idea that I was able to distinguish object A from object B. And what Broad says, and I think this is really in this kind of anti-realist vein, for me at least, it reads as something that's kind of in this anti-realist vein, because what Broad is really saying here is, well, how are you making that distinction? Like, how do you, as a scientist, right, I think about this often, I'm sitting here, I'm making theories of the universe, and I'm making predictive theories of the universe, or I'm trying to. Okay, we make a predictive theory of the universe, and it's the ultimate theory, and it predicts everything. Doesn't that mean that theory also has to predict me making the theory within it? like I am also part, if I'm taking the whole thing seriously, I'm also part of the universe. You know, the laws of physics that apply to electrons. If you know, I'm a real like hard and fast kind of scientist.
Yeah, I think even in scientism, like that's when people talk about when popularizers start talking about like determinism and free will and things like this is a very central.
Yeah, this is a central discussion, right? And so Barad is taking this observation, which I think we all agree to in science, and basically saying, well, how are you even making the distinction between an observer and an observed? Like how is it that we can't, you know, there's a kind of like a stickiness to the concept, because I can never really truly disentangle myself, the observer, from the observed. We're all sharing in the same universe, the same phenomenon, the same world. And so when we talk about what's the least biased way to cut up that pie, like what's the least biased way to cut up the universe and sort of analyze the universe, it gets really hard really to answer that question, because it's really unbiased of me to say, okay, I'm me, and then there's the universe other than me that I'm observing. Is that an unbiased cut? And how would I even make an unbiased cut in the universe is maybe a question that Barad is inviting us to answer. And so Barad sort of argues that we should replace this idea of interaction with this idea of intra-action, that we are all intra-acting in a single sort of cohesive whole, which is the universe, the world, you know, reality in its totality, whatever that might mean to you. We're all intra-acting within that space. How do you make an unbiased cut on the whole, you know, is sort of the question.
So this is a really interesting observation. But we're at an hour, and we usually do for an hour, but I want to ask you one last question. If you had to tell someone, or I'm going to ask you two questions that are sort of like back to back. So feel free to answer one or both. First off is, why should modern scientists care about this? And two, do you think that we've reached a point in certain sort of stories of scientific inquiry today, like are we at a point where actually entertaining these ideas much more deeply will be like beneficial or necessary to, I mean, this is conjecture, which is uncomfortable, but do you think certain certain disciplines are at a point where they do need to start questioning, these scientific worldviews to make progress?
I wouldn't feel comfortable saying so internal to the project of science, internal to the project of physics. It doesn't seem to me at all apparent that you need to engage with these questions to make progress in terms of what physicists consider progress. You know, physicists are making progress every day. They're quite content with the progress that they're making. In a lot of different domains of inquiry. So it doesn't seem to me that you could really say that you need to engage with this discourse. If I could pitch this, though, if I could try to sort of justify why engaging with this discourse is a good idea, I think that there are maybe two parts to that answer. So the first part is that engaging with this discourse as a scientist gives you new ideas about how to think about the world, and it gives you new ideas about theories of the world that you might concoct. And I think that that's where people like Barad are coming from. You know, their argument is that, okay, we're trying to drill down and understand what does quantum mechanics mean, you know, and how should we understand these phenomena, which even now, a century after the advent of quantum mechanics, even now we don't really have answers from a philosophical perspective, at least, to a lot of these questions about what is going on with quantum mechanics. And I think that people like Barad would say, well, maybe we need to change our perspective a little bit. If the universe can just be cut up in any way that we like, maybe thinking about it a bit differently can lead us to new theories. And I'm thinking now about these constructor theories of physics that are coming out of Cambridge. You know, these new ontologies of the universe that try to address these problems in quantum mechanics. Tim Palmer's invariant set theory. These are all really exciting, I think, new ideas in physics that people are beginning to work on. So I think that that's a pitch for it. I think the other pitch I would give is that, you know, before you're a scientist, you're a creature on the earth. You know, you live here, and you live here with a lot of other people doing a lot of other things. And if you don't embrace the sort of philosophy about the context of what you're doing, then you're not going to be considerate or careful of the impact that what you're doing is having on what you're doing is having on other people. So there's a whole sort of branch of philosophy of science that we kind of went down this branch of philosophy of science that's concerned with what is reality and how does science relate to it. But there's a whole other branch of philosophy of science that we sort of alluded to at the beginning, which has to do with what role does science play in society? What are the moral characteristics of science? How does science interact with other philosophical systems and institutions? I think both of these branches are really important. So I think that you can't really be responsible if you haven't thought about, okay, so the research I'm doing, think about the atom bomb, right? Okay, I'm going to research this project, I'm going to work on this physics, and then I'm going to live in a world where governments have the power to destroy the entire planet. Is that good for the world? Was that maybe you think it is, maybe you think it wasn't, but it's something that we should all be thinking about, I think.
Yes. So we do have a question here. So Heap of Faith says, love this. Question to you guys: how raw and pure is science/research, given the pressure to publish and produce new results? So you can go first if you want.
Yeah, I think it's the kind of project. It's just a different style of doing the projects, right? Like the pressure to publish leads you to take short-term projects that have a sort of clear path to success. And the problem with that is that if there's a clear path to success, are you really answering anything? Like, isn't the point of science, I guess one critique you'd say is, isn't the point of science to embark on research projects where we really have no idea if we're going to get to an answer or not? That happens, that still happens in the modern academic community. But I think it's safe to say, especially at the postdoc and grad student level, before you have the security of tenure, that what you're really trying to do is churn out results that are going to get you to a clear answer, and you'll be able to do it within a year. I think that one place where this applies much less is in experimental work. So John and I are both working in the context of theory, and I think this is very true in theory. In experiment, you're really probing, I don't mean to make it sound like as if this is easy, but in experiment, all you have to do is something that no one's ever done before. You set up your lab, you've got your boson sitting there.
That's it. That's it.
Like, well, yeah, like you think about, there are these we create states of matter in a lab now that are colder than any point that we know of in the universe, in a lab, and that's amazing. And all you have to do is kind of anything. And that is going to all kinds of amazing things are going to come out of that, right? People take these setups, and every year incredible experiments are being done, learning about new. There's a great thesis, catching a quantum jump and reversing it in mid-flight, and so there's a paper and then a thesis that goes with it. And this result came out about 3 years ago, maybe 4 years ago, where people were actually able to predict when a quantum jump from one energy level to another was going to happen in such a way that they could even stop it from happening deterministically. That's something that sounds totally counterintuitive if you've learned about quantum mechanics. And this is, a century after quantum jumps were first talked about. So from an experimental point of view, there's just like an endless wealth of things to be done. As a theorist, you're kind of stuck in a position where you're trying to work on what's available to you. So the experimentalist does something, and then you're trying to sort of find a way to contribute some commentary or some theory that's going to be relevant to the work that the experimentalists are doing. And that's always been true in physics. And I think that now we see a situation where the push to shorter papers means that people aren't as inclined to undertake these big high-risk research projects to say, okay, well, let's really delve into like quantum mechanics at its root. People do this in their like 40s and 50s. They do this like sort of after they've gotten tenure, after their big results have been published, once they have the security of thinking about it. But young researchers are really turned away. I mean, in fact, if you do quantum, just as an example, if you do quantum foundations as a grad student, you might really hurt your chances of ever getting a job. Because it's just considered to be a kind of like hobby relative to a lot of the rest of the field. And I think that's really unfortunate. It's too bad that we don't have more of an open academic culture, especially for young researchers who have all this energy and passion and fresh perspective. It's only once you've kind of slogged through the entire academic career path that you finally actually get to think about these problems. So
Heap of Faith commented while you're talking, from Zlatko Minev, right? I think this experiment, yeah. So I'm gonna answer the question a little bit differently, and what I'm going to propose is that in our current system, it might be a little bit better to think about scientific progress as sort of lines of inquiry that aren't up to individuals, in some sense. So I think when we popularize science and or we make a movie about science, it does really seem like there are singular movers of science, and everyone that goes into science, I think, inevitably somehow wants to be one of these movers, right? They want to move the field along. They want to make their individual contributions. But from my experience, what happens is, you go to your undergrad, you get interested in whatever you get interested in because of the things you were exposed to. You join a research group as a master's student, not really knowing anything about science. Like, your undergraduate degree prepares you in a way that you can then be like thrown into the deep end of a science project where you don't know anything. And then, so in some sense, you have no control over that. And then you start contributing to that field. Then you move on to your PhD. Maybe you move groups. You're moved on to new projects. Maybe by the end of that project, you have now gotten to maybe by the end of your PhD, you've now gotten to the point where you can start branching off from the line of inquiry that was given to you. And maybe I don't know, maybe this tree of science is going to get super complicated, but basically you start interacting with more and more people, you pick up these individual skills, and the fact that you have to publish in shorter increments will probably affect overall the quality of individual papers. But this line of reasoning and this line of inquiry that you're going through is really something that you're thrust on and something that you're a part of, rather than something that you have individual ownership over. So it's really the community as a whole, and I think that the community as a whole, I mean, like, the difference between physics. The difference between the physics in my field today and 30 years ago tells you that, I mean, we're making a lot of progress in physics today. There are still really cool papers coming out basically weekly. And all of these people are like interconnected in a way where, I mean, it's probably not useful to tell the story of physics from the perspective of individuals writing good papers, I guess is my perspective. And you're very lucky to get thrust onto these lines of inquiry, mostly through luck and partially through individual merit, that end up becoming, fruitful for one reason or the other. Yeah. I don't know if that's something you would agree with, James.
Yeah, I think that's a good way to conceptualize it. I guess my sort of maybe last word on it would be to say that, we would all be better off in a world where people were free to just follow their curiosity. If you look at the history of physics, that's how breakthroughs really come. Breakthroughs really come from people who are thinking about the thing that they want to think about. They think about it obsessively, and then they come up with some great breakthrough. Sir Isaac Newton wasn't under pressure to publish anything. And in fact, he didn't really publish very much in mathematics after he published his work on or I should say, like, he didn't it's not like as if gravity and physics were his like end all be all. He was publishing in all kinds of different areas, not because he needed to for his job, but because he was just curious about it. Einstein famously, a patent clerk in Switzerland, just doing physics in his spare time. Ramanujan, another great example of this. You kind of go down the list of mathematicians in history, and you see, these are people really driven by curiosity. And so if we want the best outcomes for scientific research, we should create contexts where curiosity is rewarded and where people are able to explore that curiosity in a way that's as open-ended as possible. We don't know what the next big leap in understanding is going to be or who's going to make it, and we don't know how many papers it'll take to publish it. So we should just try to allow people, I think, to explore these fields as best as their curiosity allows them to, and not expose all these external.
There is an optimization problem. Like, people need probably more free time away from grant proposals and paper writing than they have now. But also, I think with how many people are involved in the community today, I think publishing more regularly is also an action of inclusion.
Yeah.
Like, it does speed things up that, that you make some amount of progress that tells you the answer to a specific portion of a greater problem, and then all of a sudden people can sort of catch up with you, understand what you're thinking about, and see if they can contribute to the problem as well, rather than Sir Isaac Newton sitting there. Like there's some optimization between having your geniuses locked in a cupboard. Yeah.
Collaboration is key. I mean, I'm very pro collaboration, and I'm very pro. I'm very in favor of writing papers without results, papers that are papers that are introductory, papers that are pedagogical, review papers about null results, papers about dead ends. All of that stuff is great. And in fact, the sort of publication culture we have now, I think, really disincentivizes a lot of those kinds of publications. Yes. And I think the problem, because like you say, we just don't get a lot of... So it's not publishing in and of itself that I have beef with. It's just this culture where you've got to be sort of publishing big breakthroughs or you're not going to get selected to go on to the next round. And I think that it limits the level of participation, and it also limits our opportunity for like you say, if you've got profs who spend 50% of their time writing grants, that's time they could have just spent doing research and contributing to their field. So I think unmaking all these sort of bureaucratic burdens and all of these chores that we impose on academic work would give us a much better academic culture, probably in lots of fields, not just in physics.
Yeah. There's definitely a sweet spot, and there's definitely ways to improve the current system for sure.
Yeah.
But so I think this was a great chat. I think we left a lot on the table that can be discussed in the future. I hope you don't mind me saying, but James and I have discussed making this a little bit more regular, because we've taken like a several months gap between the last show, but I think we'll do this again maybe in a couple weeks. But thanks for everyone who watched. I hope you enjoyed the show, and thank you again, James, for coming on and talking to us.
Yeah, thanks for having me, John. It was great to chatting with you again.